Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be continuing optimization, but this time with prices. So it's going to be a lot of fun, I'm sure. So just as a recap, optimization are those problems like you have a rectangular fence and you have some constraint, like for instance, you only have 300 yards of fence and you want to choose the dimensions X and Y that give you a maximum area to fit your whatever. The difference is now we're going to be adding in prices, and I'm going to explain how that affects the problem. Most of it stays the same. This really just affects the first step, which is coming up with the objective and constraint equations. If you don't know what I'm talking about, definitely check out my other video on optimization, because if you don't know how to do the easy optimization problems, then there's no way you're going to be able to do these ones. So let's just step into an example. Let's say I am going to build a rectangular fence here. Now, 3 sides of my fence are made of wood, a normal wooden fence. But this side right here, I want to be made of rocks, a nice rock fence. Looks very aesthetically pleasing. Now, the problem is wood is going to cost, let's say, $30 a yard for all 3 of these sides. But the rock side, let's say that's more expensive. It's 60 yards. I got to pay someone for the installation. There's a lot of mortar or whatever it's called that keeps the rocks together. But here's the thing. I'm working on a budget. I have a budget of $8,000 to build this fence. I want it to be a big fence. And the question is, what is the largest possible area that I can build for the fence? Okay, so step 1 starts out the same way. I need an objective and a constraint equation. Remember, the objective is the thing we're trying to maximize or minimize. In this case, that is the area. In this case, area is going to be, I'll say, x times y, where this dimension's x and this dimension's y. So that's the objective. Done. Constraint is the number, which is the money, 8,000. So 8,000 equals, and then how do we set up an equation for this, right? So here's what we're going to do. The budget and the cost is tied to the perimeter. In other words, it's 60 yards for this side, which is y, $30 per yard for these 2 sides, which are both x on the top and bottom. And then this last one is also $30 per yard, but that's going to be for a y side. In other words, if I want the total cost, the top and bottom are both going to be 30x, the right side's going to be 30y, the left side's going to be 60y. I just multiply the price by the dimension. I repeat, I just multiply price by dimension. That's how we do it. And so then plugging in, I'm saying 30x plus 30x plus 30y for the wood side, and then 60y for the stone rock side. And I can simplify that. So 8,000 equals 60x plus 90y. And now I need to solve for either x or y. Doesn't matter which one. I'll choose to solve for x. So that means I'm subtracting 90y from both sides. 60x equals 8,000 minus 90y. And then I have to divide everything by 60. I am going to use a calculator for this because this is going to get really annoying and I don't feel like doing weird algebra. So 8,000 divided by 60 is 133.3. And then minus, that's going to be 1.5y. If you're not allowed a calculator, that's fine. Just simplify this as much as you can, but don't worry about it too much. So now that x is solved, what do? I plug that x back into the objective equation right there for x. So it's going to be area equals x, which is 133.3 minus 1.5y, and that's going to be times y. Remember, the next step is taking the derivative. So before I take the derivative, it'd be a good idea to simplify as much as we can by distributing the y to both terms. 133.3y minus 1.5y squared. Remember, this is just the function, not the derivative yet. So now for the derivative, a prime, that's going to be 133.3 minus, power rule, 1.5 times 2 is 3, y There we go. Derivative is done. Okay, next step. This is the first derivative test. That means we're setting this equal to 0, solving, making that number line, and testing the points, positive and negative, to see if we have a maximum or a minimum. So first, that means solving for y. I will add 3y to both sides, and then we just divide by 3. This one's pretty easy. So y is going to equal, again, getting out my calculator, that's going to be 44.4. Units are yards. And again, this is where I'm going to set up a number line. So here's 44.4. I have to test a point above and below and plug it into my derivative, which again was 133.3 minus 3y. So first I'll plug in 1, because that's less than 44.4. 133.3 minus 3 times 1, that's going to be 130.3. Definitely positive. I don't care about the number, I just care positive or negative. And then if I plug in a number bigger, like 50 for instance, 133.3 minus 3 times 50, that's going to be 133.3 minus 150. That's definitely going to be a negative number. I don't care what the actual number is. And look at this. I have positive to negative. That means it's going to be a maximum, which is great because what did we want? We wanted the maximum area for this field. So the y dimension is going to be 44.4 yards, and that is the maximum y dimension. However, that's not what the question asked for. The question did not ask for dimensions. It wanted the area itself. So in other words, we want the x times y value. It would help if we knew x. The good news is we have an equation for x from the very beginning right here. When I solved my constraint equation, x equals 133.3 minus 1.5y. So 133.3 minus 1.5 times y is 44.4. And so then I just have to plug this in a calculator and we'll have x. That's going to be 66.7. And then finally for the area, it's x times y. And just so you know, when I am plugging this in my calculator, I am storing all of the decimals. I'm just rounding it here on the computer screen because I don't feel like writing a lot of decimals, obviously. And that will get me a final area of 2,963, approximately, yards squared. And that is the maximum area I can have. Pretty big field. So one more time, how did we deal with the prices? We just multiplied the price by the side lengths. In this case, it showed up in the perimeter equation. It's not always going to show up in the constraint, but most of the time it will show up for perimeter or surface area. The prices usually don't affect the area or volume for a 3D problem. So with that in mind, we have one more we're going to do today. For this one, I'm going to be building a box, and it's a beautiful box if I've ever seen one. And we are going to be painting this box today. So I want blue paint for the top and for the bottom, and then I'm going to be using red paint for all 4 sides. Now, as we all know, red paint only costs 25 cents per centimeter squared, but blue paint is more expensive. You know, it's harder to get those color pigments, and it turns out that's going to be 60 cents per centimeter squared. Now, this box is going to have a volume of 100 centimeters cubed, and it's going to have a square base. But where we have the liberty to decide, we get to choose the dimensions, length, width, and height, in order to minimize the cost of making this box. So one more time, the question's asking for the dimensions, length, width, and height. And as a quick hint to you, since it's a square base, get rid of W, just call it L. So we have 2 L's here on the bottom. So go ahead, pause the video, see if you can do this one on your own. I guess one more thing I should tell you, although technically you should know this. The volume of a rectangular prism is length times width times height, and the surface area is 2LH plus 2LW plus 2WH. Again, this will not be given to you on the AP exam, so you're going to have to memorize that when that day comes. But for now, pause the video, give it a try, and when you're ready to see the solution, unpause. Okay, so this one's definitely going to be tougher. First of all, hopefully you said that the objective is cost, and cost is related to the surface area, like I said earlier in the video, which first, I guess I could say area is 2LH plus, remember, W is really L, like I said before, W equals L, so that's 2L squared, because L times L is L squared, plus 2WH is also going to be LH. And I can simplify this to make it 4LH plus 2L squared. Remember that the 4LH, that is the sides of my rectangular prism. Why? Because length times height and width times height, if you look at the picture, that represents the area of the sides of the rectangular prism. And the top and bottom, that's going to be the L times W, or in this case, 2L squared. So that's the top and the bottom. Now obviously, this isn't price yet. I just wrote the area equation to help me get the price, or cost. The cost is going to be the sides times their cost, 0.25, because that was the cost of the side, plus 2L squared times the price of the top and bottom, which for blue paint is 0.60. I can reduce this. I will reduce this. It's going to be cost equals LH plus, that's 1.2 L squared. Okay, we're done with the objective. I know that was a lot. The good news is the constraint's going to be a lot easier. So for the constraint, this is going to be the volume. Why? Because I said the volume was 100. The random number they give us is always the constraint. So constraint 100 equals volume formula, length, width, height. But remember, width got replaced with L, which means that's going to be L squared H. Okay, hardest part of the problem is done. Objective is this right here. Constraint is this. What do we do next? We're going to solve the constraint for one of our variables. I'll choose H because only a lunatic would try and solve for L here because it's squared. So H equals 100 over L squared. I'll then plug that in right there for H, and we'll get the cost equals L times 100 over L squared plus 1.2 times L squared. Before I take the derivative, it would be a very good idea to reduce this as much as we can. So one of the L's cancel, leaving me with 100 over L plus 1.2 L squared. Okay, now it's time to take the derivative. Actually, let me rewrite this as 100L to the negative first, because that's going to make it easier to take the derivative. And now we'll take the derivative, find the critical points, stuff like that. So doing an easy power rule, we'll get negative 100L to the negative second plus 2.4 L to the first. We have to set that equal to 0 and solve. My advice is move this L to the negative second back to the denominator. It's going to make it easier to solve, and we're allowed to do it. And now if I want to solve for L, what I'm going to do is I'm going to multiply everything by L squared. And just remember when we do this, that L cannot be 0 because 0 cannot be in the denominator, and we're going to miss that solution later on. But anyways, distributing the L squared gives us negative 100 plus 2.4 L cubed equals 0. And now we just need to solve for L. I'm going to add 100 to both sides. Then we'll divide by 2.4. I need a calculator. That's going to be 41.667. And then we take the cube root of this, and that'll give us our dimension for length, 3.467. That's going to be in centimeters. And again, I still have to test that this is a max or min by plugging it in a number line. Don't forget 0 is going on this number line too, because even though it's not a critical point, it's a domain error. So I cannot choose numbers 0 or less to test with. And I'm plugging this in the derivative, negative 100 over L squared plus 2.4 L. And so first I'll test a number like 1, negative 100 over 1 squared plus 2.4 times 1. That's definitely going to be a negative number. And then if I plug in a number like 10, negative 100 over 10 squared plus 2.4 times 10. That's going to be -1 plus 24, which is definitely positive. Looks like we are getting a minimum here for the length. Did we want a minimum? Yes, because we wanted the minimum cost. So length is going to be 3.467 centimeters. We know the width is also 3.467 centimeters because it's a square base. And now all we need last is the height. Remember, the height was in our constraint equation back here, 100 over L squared. So that's going to be 100 over 3.467 squared. Plugging that in the calculator, that'll get us 8.320 centimeters. So finally, the dimensions. 3.467 is the length by 3.467 centimeters is the width by 8.320 centimeters is the height. And there's our answer. If you have any questions with that, please let me know in the comments. If not, have a great rest of your day. Keep on practicing these because, they're pretty tough. And I'll see you in the next video. Take care and bye-bye.